Hello, everyone. Let me start by introducing myself. I am Carla Girdi, and I will be your host today. I would like to thank you all for attending AITS Tech Talk webinar. Today, our colleague Janine Kuta will take us through the Aveva Telemetry Server, its features, basic components, and after, we'll dive into the technical demo. Please leave all your questions in the question section, and we will answer them at the end of the session. Now let's get started. Hi, Janine.
Hi, Carla. Thank you. Thank you, everyone, for attending this webinar. Let's go through the agenda, first of all. First, we will be going through the definition and features of the telemetry server. Second, the 4 major components of the telemetry server are discussed. We will also take a look on the basics of the DMP3 protocol and explanation on how to connect between system platform and the telemetry server. Finally, we will be demonstrating some examples for configuration and redundancy. The telemetry server enriches the integration of industry verticals such as power distribution, water, wastewater, oil and gas with the system platform. It provides a complete connectivity package tailored specifically to geographically distributed applications that leverage communications protocols such as DMP3, IEC, and Modbus. The telemetry server supports both master-slave communications of different media types, such as TCP/IP, Ethernet radio, serial RS-232, RS-485, modem, which is dial-up. It captures data using low bandwidth optimization and supports buffered data events. It is fault tolerant, where it can be configured as dual or triple redundancy. It leverages platform services, which is PSC, for automatic communication discovery and reconnection. Security is embedded by default, and it contains a built-in customizable application security configuration. Let's first discuss the telemetry server 4 major components. Telemetry channels are the communication lines through which information is passed between the telemetry server and the outstations on your system. Outstation set is a group that shares one or more channels. All outstations in a set communicates with the server using the same driver-specific protocol. An outstation or remote terminal unit gathers data from and sends commands to the plant. The plant is represented by points in the telemetry server, for example, analog points, digital inputs, analog inputs, outputs also. Finally, it is beneficial to note that a group can be created to allow to create complex hierarchies that reflect the design of your system. Typically, you use groups to organize database items according to their geographical location, their type, and their purpose. DMP3 is a protocol for transmission of data from point A to point B using serial and IP communications. It has been used primarily by utilities such as the electric and water companies, but it functions well for other areas. DMP3 uses the term outstation to denote remote computers as are found in the field. The term master is used for the computers in the remote centers. An objective of the master is to keep its database updated. It accomplishes this by sending requests to the outstation, asking it to return the values in the outstation's database. This is termed as polling. The outstation responds to the master's request by transmitting the contents of its database. A DMP3 frame consists of a header and a data section. The header specifies the frame size, contains data link control information, and identifies the DMP3 source and destination device addresses. The data section is commonly called the payload and contains data passed down from the layers above. The Modbus protocol allows controllers to communicate using a master-slave technique in which only one device, the master, can initiate transactions called queries. The other devices, the slaves, respond by supplying the requested data to the master or by taking the action requested in the query. Typical master devices include host processors and programming panels. Typically, slaves include programmable logic controllers. Version of Modbus protocol exists for serial port and for Ethernet and other protocols that supports the Internet protocol suite. There are many variants of Modbus protocols such as RTU, ASCII, and TCP/IP. IEC protocol, the protocol created by the International Electrotechnical Commission, which is a standard that defines system used for telecontrol. Such systems are used for controlling electric power transmission grids and other geographically widespread control systems. For example, the 6870-5-104 enables communication between control station and substations via a standard TCP/IP network. The TCP protocol is used for connection-oriented secure data transmission. Application server has a direct interface to telemetry server, which allows dynamic remote configuration of the field points. The telemetry server needs to be configured to connect to the remote terminal units. Like other communication drivers, the points configured can be done locally within the telemetry server or remotely from the client application. To send and receive data, you will need to configure the I/O attributes in accordance with the applicable communications protocol. Use the reference syntax that corresponds with the protocol you are using. Since some outstations may send data to the telemetry server only once per day, we will also need to enable buffering to ensure that data is not lost. So basically, what is that buffered data support? So telemetry server supports storing and forwarding the VDQ, value, time, and quality, data that has been buffered in the RTU for a period of time. The attributes in the application server must be enabled for buffered data, support to allow the engine to process incoming buffered payloads from the telemetry server. Finally, let's discuss the referencing. Static references. Points that have been created, defined locally within the telemetry server can be referenced from the client application. Using the static reference syntax, well, in this type of referencing, you need to specify the following. The node name is the name of the computer node where the telemetry server instance is installed. The full group path name is the full hierarchical name of the group levels where the point is configured. Finally, the point name is the identification name of the point inside the telemetry server. For example, here, the node name is ADS001. The path name here is region 01.01A, which is the hierarchical name in the telemetry server. Finally, the point name is the pump_pressure. Dynamic references. You can dynamically configure the points in the telemetry server from the client application using a special syntax that has the required context to generate the tag type and the tag name for you within the specific protocol set. When you create a dynamic reference from the application server, the point is automatically created in the telemetry server, eliminating the need to manually create the same references in two places, which is the system platform and the telemetry server. Here, instead of the node name, we put the scope name, which is configured inside the platform communication services, the PSC, which we will be explaining later on during the demo when we discuss redundancy. Okay. Also, we should place the the outstation name after the full path. After that, the point type is specified. For example, DI for digital input. The syntax and specific items depend on the type of protocol used. For example, if DMP3 is used, this is the point number. Here it's 2, which is, for example, the address for the point. For example, here the scope name is ATS001. The outstation name, as you can see, is shown after the path by putting a dot outstation 001. The point type here is a digital input, which is DI. I'm using here actually basically a DMP3 protocol here. So 2 is the address of the point, which is the point number. Now, and I will be demonstrating some examples. We will be configuring a DMP3 master and slave stations inside the telemetry server. Second, we are going to connect to the system platform. After that, we will apply and test redundancy. Let's go to our machine. Okay, first of all, let me close the system platform. Okay, let me first of all, in order to run the telemetry server, you go to the start menu, Aveva Telemetry Server, and you click on the telemetry server configurator. Okay, in order to do your configuration and create your master and slave. As you can see, a password is required because private security is enabled here. Okay, so now I logged on. Okay, let me double check this one here. Okay, all right. So first of all, I will start by creating a group. So I will go create a new group. I'm going to call this group to be the master group. Basically, in this example here, since the telemetry server is used to create both master and slave, I'm going to create both the master and slave today inside the telemetry server. I create the master group second. The second important, which is the channel, as discussed earlier. Basically, you see here, I have several options. I can either create a DMP3 master, I can create a DMP3 slave, I can use the IEC-5 standard, and also this is a master, this is a slave. I can also configure a Modbus connection, and finally using the OPC protocol. So let me go back to the DMP3 channel. I create a channel, click on, I'll name it channel. Okay. Okay, you see here, I have an X here. It means that the channel has not yet been configured. I'll double click on that to configure it. You see here that I have some notifications here to tell me that some configurations are missing. I'll put this one in service, first of all, my channel in service. Second, the connection. I'm going to use for today the networked connection and TCP/IP. You can choose UDP or TCP. Okay, click on save. Actually, it's not yet configured. You can see that the line speed is still missing. The good thing here is if I double click on that, it will take me automatically to the field that has not yet been configured. So I will choose the highest speed and click on OK. Just make sure always that your channel is in service. Okay, now we're done with the channel. Let me close it. The second component is the outstation set. So click on New, DMP3, the outstation set. So I'll use a direct outstation set. I'm going to call it outstation set. Not configured yet. I'll double click on it, put it in service. Note that each outstation is required to have a channel. So this is required. So here I will choose the corresponding channel already created. the DMP3. So the local address here in today's webinar, I'm going to use 30,000. So I'll click on save. Let's check if everything is okay. All right, so I'll close this one. And the third component is the outstation itself. So the DMP3, I'll go to the MP3 master, generic this time, and direct outstation. So I'll call it outstation. Okay. Let me double click on that to configure it. Always put it in service. It should be connected to an outstation set. I'll choose this one. The DMP3, I'll configure the DMP3 configuration. So here the address here is 4321. Okay, I will not enable security. The network, it's single network. And the address, because I'm using today's current machine, it's going to be the local host, and the listening port is going to be 20,000. Okay, here. All right, let me check if everything's fine. I would like always to check if my components are in service. All right, so everything's okay. Now, after creating the three components, major components, we should create the points, which are, the connection between the field devices. Let's suppose here I'm going to create an analog input. So here I'm going to go create an analog input. All right, AI, right. So this analog input, I should always put it in service, and then it will be linked to an outstation, which is already configured. The most important thing, because I'm using the MP3, is to specify the address of this point, which is the point number. In today's webinar, it's going to be 1. So I'll click on save. Everything now is well configured, hopefully. So now, in this webinar, the telemetry server contains both the master and the slave. So the communication between those two is done internally in the telemetry server. But I could go ahead and right click and continue on, create a new group for the slave, and create a channel, outstation set, and whatever. But now it will be like, I will import it now because I've already created a configuration, previous configuration. So I'm going to use it and import it directly to the telemetry server. Let's go through some of the DMP3 slave configurations. First of all, the direct channel. Okay, it's using the same connection type. In the direct outstation, I'm using the 4321 address, and I'm not using security. Here, it's very important to note that this is called localhost. This is the same IP address I'm using here. So this is the local host. I should save that, go to the direct outstation. Everything here is configured. Let me note one more thing here for the direct channel. It's that I enabled the listening port, which is the 20,000 here. Okay, so I think that's it basically for the configuration. Let's hope I did everything correctly. So now you can see here that, wow, it's already online, and the value here, it's showing 83, and it's good. It's of good status. Actually, my telemetry server is communicating internally. So great. So let me refresh this. Okay, so it's stuck on 83. Okay, all right. So let me jump now to the second part, which is how to connect the telemetry server to the application server. Before jumping there, let me just take you to something that you're going to be needing later on while configuring the IO address. View the status here again, sorry. You will see here that the full name here is DMP3_master_AI. Well, this is going to be the point name inside the telemetry server while I do the referencing. Basically, as mentioned before, we have two types of referencing, the static and the dynamic. But in today's webinar, I'm going to use the static referencing. Okay? So let me jump to the IDE. I have already created here a platform, which is deployed, just the GR node here. But I have an app engine running, and I have I have created an area and then a user-defined object. So basically, I have tried it before. I created an attribute, which is an integer type, and I have already used the static referencing for that. So I'm going to use the same thing. So I'm going to create a new attribute. I'm going to call it PV2 this time, and I'm going to put it to be as an integer. This is very important because you want it to be an integer because the AI is an integer type. It could be a float type if you want to, but I'm going to use integer for today. So click on AI. Now I'm going to copy the same thing from here. All right, so click on copy for this one. So note that the node name here, it is the GR node. So here, oops. So here, let me just delete that. I guess let me just paste it one more time. I'm sorry for this. Okay, so basically the GR node here is the node name. Okay, and the address, which is dmp3, and be careful here, it's case sensitive. dmp3 underscore master dot AI is my point name as specified in the telemetry server. So let me double check if that's okay. All right, so let me save here. Okay, 1 second. Let me save here this one. Oops. Okay, so click on OK. The object is being checked in. Let me deploy and check what happens now if the object is deployed correctly. So let me go to the object viewer. Now you will see that. Let's check PV2. So actually, this is PV2, which is giving me the 83, which is of good status. Hope, thanks God. And if you want to check the input source of this, sorry, it's right here. So it's good, and it's specifying that the input source is the telem server gr, the dmp3 underscore master. This is the address, the value of the address used. So basically, this is the easiest way to connect. Not the easiest, but this is, you can use the dynamic referencing as well if you want to. It could be also easier. All right, so basically that's it for connecting to the system platform. Now let's talk about redundancy. So as mentioned earlier, you can have triple redundancy. You can have like pair working together, like a pair. Now let me talk about my configuration here. My system here actually, it contains, now we have two nodes running. The first node, it's called the GR. The second node, it's called the prod node. Now on each node, I have installed the telemetry server. How do we configure redundancy? And how do we test redundancy? Let's jump to the first node. Let me close that. So I want to close that as well. Not going to need it. So basically, in order to configure redundancy, two important parameters are needed. The first parameter I'm going to need, oops, I have security here, in order to configure the server. Sorry for this delay. Basically, the two important parameters to configure, first is the partner configuration. So if I go to system configuration here and double click on this partners here, the server label, which is the current node name is the GR platform. I have the type here is a hot standby pair, but you can use such as triple pair, etc. My partner has this following IP address, and the listening port or the communication port between the between the two between the pair is for this port here, 5481. Note that this port should be excluded from your antivirus and firewall configurations. This is really extremely important, or your redundancy will not take effect. All right, so that's it for the first parameter. The second very important parameter and mentioned earlier inside the presentation, it is the PS service, which is the platform communication service. So here you should configure the scope name. What is the scope name? Actually, the scope name is used for redundancy, and both nodes should have the same scope name. You can choose either node. For example, here I choose the first node, which is GR platform, but practically for the second node, all right, let me just, oh, it's offline. But for the second node, I will connect this now. You'll see what's going on. For the second node, the scope name should be the same. Now look what's going to happen. Let me go back here. So in order to see the status of the telemetry server running, you just click on this icon. So this icon now shows me telemetry server main. So this node is acting as my main node. So let me go back to the production node and turn the node on, turn the server on. I'm going to start the server. Well, actually, it's going to take a couple of seconds, but while it's starting up, it will synchronize. And while it's synchronizing, you will see like a round golden flashes. So let me just monitor that. It's going to take me like a couple of seconds. So here, let me just wait, please. All right, so here you see the golden flashes here. It means that's synchronizing. And then you will see that the telemetry server is standby. If you want, I can show you that the same, sorry for that, let me repeat this again. Okay, so let me show you inside the telemetry server here. It's very important to note that the same configuration I did in the first node, which is the main right now, it's copied automatically to the second node. You don't have to do any configuration here. And vice versa is applicable. For example, if I go and change something here, like for example, let's create anything here, it will be automatically updated, or the second node will be configured based on that. So you don't have to do any changes on both nodes, just do it on one, which is very easy. I wanted to show you here the important parameters again for this server here, which is the standby server right now. Okay, let me use this one here. Oops, sorry for this again. All right, so basically here the system configuration, the partners here, I have created also the same configuration. I have specified the IP address of the second machine, my partner, and the same port, listening port. But here the server label, of course, is going to change because this is the name of the current machine, which is the prod platform here, for instance. The very important parameter I wanted to show you is the PS surface. Actually, you see that on both nodes, the scope name is the same. This is very important, which is the GR platform. I can put here a prod platform, but over there it should be prod platform as well. So I'm not going to change anything. Now let's test some redundancy. So as mentioned before, this TLM server is acting as my standby. What happens if I go over there? Let me close this. I'm not going to do any changes. What happens here if I go and shut down the server? What will happen? So of course, shutting down the server requires also some security. All right. Are you sure you want to shut down? Click on yes. You will see now this is shutting down, but what happens to the other? Actually, now the other becomes the main. So now this is the main server instead of the, and by the way, it gave you the timestamp, sorry. For example, here it's right now like 12:29 for instance. So basically, configuring redundancy and testing redundancy is very flexible and very easy. It will take you just few minutes just to configure and test. All right, so basically that's it. Thank you for watching today's webinar. I hope you enjoyed and find it beneficial. Thank you.
Thank you, Janine, for this informative session. We will give the audience a few minutes to type in their questions. Meanwhile, please be reminded that today's webinar recording will be sent to you by email. And also, you can find it in all our social media platforms. So make sure to follow us to stay connected and updated with all our news and webinars. The links are already in the chat box. All right, let me start reading the questions that we've received. So, Janine, how can we configure security in the telemetry server?
Okay. Thank you, Carla, for the question. Basically, configuring security is very easy. It's just, I'll show you just, the first steps to do that. If you right click here, and you can, first of all, you can click on edit security. For example, you can also create, let's say, security groups. You can create security users. For example, here I created a user. You can, for example, add this group to this user to certain groups, and you can, when you added the security, you can put some permissions or restrictions to certain groups and others. So basically, it's very easy to embed security. I hope this answered the question.
Okay. We received another question. What are the differences between an OI server and telemetry server?
Oh, that's a good one here. Okay, so there are basically, there are some differences between the OI server and telemetry server, but let me mention like two of them. The OI server, basically, it captures live data by using real-time data updates from the drivers. On the other hand, you can say that the telemetry server uses a late data format where the device reports information based on their need. All right, this was the first difference. The second one I can, okay. The OI server uses mostly the LAN, the local area network connection, while the telemetry server mostly uses the WAN connection, world area network connection, such as radio network, stuff like that. So basically there are some other differences, but if you want, I can send them by email. Maybe it will be more clear. I hope this is enough.
Okay. We have another question from Stefan. For DNP3, will incoming socket connection be supported? Connection to be initiated by the field RTU and not the server?
Well, Carla, can you please repeat the question?
Yes, sure.
Sorry for that. Yeah, sure.
Yeah, sure. For DNP3, will incoming socket connections be supported? Connection to be initiated by the field RTU, not the server?
Yes, well, actually, yes, it will support connections, and it shall be initiated by the RTU based on class configurations. If this is what he asked for, basically.
Okay. So I guess we're running out of time. We received some more questions. We will reply to you guys by email, answering all your questions, as well as the webinar recording will be sent to you. So thank you all, and thank you, Janine, again for this webinar. I hope this session was very informative. Thank you, and see you next week with a new topic. Goodbye, everyone.